100 out of 100. That's why yes, I actually like math lesson.
Okay. And also, actually, as I heard from Mr. Adalat, and you may actually participate in SASMO. As you know, this SASMO is the Singapore Math Olympiads. And
Yes.
my name is Abdul Qasim, but you can call me just Mr. Qasim. And I have been teaching math for maybe around 20 years. And also I used to prepare students for such Olympiads. And now I'm teaching at the university. Anyway, as we actually go, um, how to say, as we spend more and more time together, we will actually know about each other more. How it works actually. Here, I'm going to teach and I'll try to explain everything in detail, but intensively because we don't have much time. And after each lesson, you're going to have some homework to do. Okay. You have a telephone, right?
Yes.
Okay. Then you need to actually install this cam scanner from app. What is it? If you're your iPhone, that is Apple Store, or if you're using Android,
I
that
use
is
iPhone. Can you
okay.
please like write in chat the name
Yeah, yeah.
of the app?
I will tell you a bit later. Okay, there's one app, Cam Scanner, and you need to
Mm-hmm.
do your homework on A4 size paper, and you have to scan it with that app. And after that, you should save it as PDF. It's very easy to use. I'll show this a bit later because also waiting for other students. And after that, you have to send your homework maybe through WhatsApp or to my email. So if you have WhatsApp, you need to actually, I open one group. If you just say hi, I will add you to this group. We will communicate with each other through that group. Okay, the name of the group is, anyway, this is my WhatsApp number, 8. Sorry. You can see my screen, right?
Yes, I do.
Okay, this is my WhatsApp number, 855-959-8281. And if you just say,
Okay.
hi, I'm grade 7 and my name is Salim, I will add you to this group, okay? So if you have any question when you are doing your homework, anything related to this lesson, actually you can contact through that WhatsApp, okay?
Okay. Thank you.
So now I'll just share you what topics we are going to learn. You need to have a look quickly, and after that, actually, we will just start new level. But of course, going through this topic, it takes around maybe 3 months. Okay, let me share. Okay. All right. So what do you see on the screen?
I see the
Can
um
you can you read it?
like yes, but I'm on phone joining the lesson. That's why it's really hard to like read because it's too tiny.
So
Can,
you join with your telephone?
yes.
Oh, actually, do you have laptop?
Yes, I have, but there's no WhatsApp. So my mom actually messaged me the link, and I
Uh,
joined from phone. That's why.
okay,
But
actually,
I
if
see now
possible,
you.
yeah, maybe next time you need to join with laptop, and sometimes I may ask you to do something, or we may have some discussion. That's much better. Anyway, so these are the topics we are gonna how to say study. Okay, maybe if you're good, we will go fast. If you are a bit weak, we will get a bit slower. So starting with factors and multiples, you might know this, but still we need to revise so quickly. Integers, rational numbers, estimation and approximation, fundamental algebra, number sequence, and the algebra equations and simple inequalities, perimeter and area of simple geometry figures, volume and surface area, ratio, rate, and speed. Anyway, it's just going, we have around 16 different topics here. Some are related to each other. So we are going to study these topics within maybe 3 months. And after that, we will start another level. and maybe 2 more months. And after that, we will practice harder questions, more challenging questions. Okay.
Okay.
All right. So now today, let's talk about factors and multiples. What we have in this chapter, we'll talk about factors and multiples, prime numbers and composite numbers, prime factorization, index notation, highest common factor, least common multiple, squares and square roots, cubes and cube roots, mental estimation, the use of calculators. Anyway, so do you remember these factors, Salim?
Yes, I think that factor is the maybe the numbers that used to create a multiple.
Okay. So before we start this, let's just talk about two things. Okay, number one is natural numbers. What do you understand when you say natural numbers? What are natural numbers? What numbers are called natural numbers?
For example, 1, 2, 3, etc., and the positive integers.
Very good, very good. Actually, the numbers that are used to count the number of objects, right? Like number of people, number of cars, number of anything. So we call this natural numbers. And the smallest natural number is 1. And after that, just to get the next number, we need to add 1 dot dot dot. These are natural numbers. And how about whole numbers?
Whole numbers are, for example, the whole, not the fraction or something like this, like 1 the whole and 2 whole, like this.
Yeah. And the only difference is when it's just a whole number, also actually it starts with 0, right? 0, 1, 2, 3. These numbers are called whole numbers, right? And about integers, I don't want to talk about integers. We'll talk about integers a bit later. Right now, we will talk about the first thing, maybe the second one or the first one, natural numbers. Because when we talk about factors and multiples, we talk about natural numbers, right? As you said, what is a factor? Factor is a number that divides a natural number without leaving any remainder, right? For example, let's say, if I say, what are the factors of 6, for example? What are the factors of 6?
2 and 3.
Factors of 6, any number that divides 6 without leaving any remainder, right? So actually, 1 divides any number because 6 is divided by 1 is equal to 6. It's a whole number. How about the 2 is also a factor because 6 is divided by 2, it is 3, right? And also 3, 6 is divided by 3, it is 2. You see here, the quotient is a whole number. Actually, it's a natural number. And what is the next one? 6. So the 6 has 4 factors, right? The only numbers actually that divide 6 without leaving any remainder. How about the factors of 10?
So 1, 2, 5, and 10.
1, 2, 5, and 10. Very good. Like this, you can just count this. For example, let's say 24. Let me just not write factors. What are the factors of 24?
1, 2, 4.
3. 3 also divides 24, right?
Okay, 3, 4, I think. Yes, 4. 6 and 24.
And how about 8?
Oh yeah.
24 is divided by 8, also 3. And how about 12?
Yes.
Also 12, right?
12 by 2 will be 24 and 24.
And 24. Good. So that's the factor. Simply, it's a number that divides another natural number without leaving any remainder. And how about the multiples? Multiples. So when it says that multiples, for example, what are the multiples of, for example, 4? That means that all the numbers, natural numbers, that are divisible by 4, we call them multiples of 4, right? Actually, to produce the multiples of 4, we should just multiply this number by natural numbers, right? Multiply by 1, we get 4 here. And if you multiply by 2, we get 8 here. If you multiply by 3, we get 12 here, dot, dot, dot. So these numbers are multiples of 4. And how about the multiples of, for example, 5? And to get the multiples of 5, we need to multiply just 5 by these natural numbers. 1 times 5, it is 5. 2 times 5, it is 10. 3 times 5, it is 15. 4 times 5, it is 20, dot, dot, dot. Okay, now you have some idea about factors and the multiples. So the question, list the factors of 60. Can you do this? Can you just tell me all the factors of 60? What are the factors of 60?
So 1, 2, 3, 4, 5, and 6.
Okay, continue.
10.
10, very good.
And 60.
And how about 12?
12, okay.
Also it divides, right? And how about 15?
Yes, and 20 and 30.
20 and 30. And
I think that's it.
And 60 itself, right? And usually
We
to get the
count the
factors.
60.
Sorry, say again.
We count the number itself.
Yeah, of course. Because
Okay.
what is 60 over 60? Is equal to 1, right?
1.
Is
Right.
1 a whole number? Yes. Then it is a factor, right? And what is the definition of a factor? It should divide a number without leaving any remainder. If you divide 60 by 60, there will be no remainder. What is the remainder here? Remainder is equal to 0. Okay. And actually here, what is the technique here to find the factors? You should just starting with 1. I can write 60 as 1 times 60, or 2 times 30, or 3 times 20, or 4 times 15, or
5 by 12
times 10, right? And what else? And after that, it is 10, it just repeats. It is 10 times 6, dot, dot. So actually, these are the factors, right? 1, 60, 2, 30, 20, 4, 15. Now it's just repeating here. After this 6, 10, now 10, 6, so we can just stop here. All of these numbers, as you see, these are the factors of 60. And how about B? Can you just tell me some multiples of 5? It says list the multiples of 5. Just let's say 5. What are the multiples of 5?
5, 10, 15, 20, and etc.
Good. All right. So now let's talk about another special number, prime numbers. What is a prime number? Also, you might remember this. What is a prime number? It is also a natural number, right? Which has exactly 2 different factors. Now you know what is a factor. So we have some numbers, actually these are special numbers. If they have exactly 2 different divisors or factors, we call them a prime number because it plays really important role in some problems. That's why actually it deserves to have a special name. So a number which has only 2 different factors, 1 and the number itself, is a prime number. So what is the smallest prime number?
2.
Very good. 2. And next prime number, which has only 2 factors, 1 and itself. What is it? 3, right?
3.
And next one is?
Then 5, 7, 11, 13, maybe.
Very good. So these are the prime numbers. Now also you know what is a prime number. And how about if a natural number has more than 2 factors? At the time it is called a composite number. What is a composite number? It's a natural number that has more than 2 different factors. Actually, for example
18.
For example, let's say this 4, right? What are the factors of 4? 1, 2, 4. It has more than 2 different factors, right? 6, composite number. 8, composite number. 9, composite number. What are the factors of 9? 1, 3, 9. Okay, these are composite numbers. Now there's a question here. The number 1 is neither prime number nor a composite number. Why?
Maybe because it has less than one factor.
Because it has only one factor itself, right? Only one factor. Because we're just defining prime number, we are saying that 2 different factors, but it has only one factor. That's why it's not a prime number or it's not a composite number. Very good. Now I have a question for you, Zalim. And maybe after 10 minutes, I can give you some break for 5 minutes, and after we'll continue. So Salim, here, 2 examples, 37 and 73. These are prime numbers with reverse digits, right? If you just reverse the digits of 37, we get 73. And both numbers are prime numbers. Question 40, can you name another pair of 2-digit prime numbers with reverse digits? Can you just give me a similar example like this? When I just reverse this, still it's a prime number.
Maybe 67.
Are you sure?
No,
67.
no. Maybe 1 second. I'm gonna think. 31.
Very good. It is 13 and 31, right? Any other one? Can you name one more?
Okay, 71.
71, very good. It
And
is
59.
17 and 71.
59.
Any more? One more?
Maybe 59.
Are you sure? Because 59 and 95, 95 is not a prime number, right? Because it's divisible by 5.
Yes, I didn't think about this. Then 11.
11? Yeah, it's still very good. Any other number actually different from this 11? One more, just tell me one more, then you'll go to the next slide.
Okay, 97.
97, are you sure? So that is 79 and 97. So 97 is not divisible by, is it a prime number?
No.
No? Yes or no?
It has less or more factors. 1 second. 97.
Yes, 79 is a prime number, right?
Yes.
And also 97 is a prime number. Good. All right, just okay. So now let's talk about prime factorization and index notation. And now you will see the examples that actually prime factorization is really important in some kind of problems. Anyway, here, after all, we are just doing some kind of revision. At least you remember these things, and after that, we'll try to solve some challenging questions related to these concepts. So every number except 1 is either a prime number or a composite number. Now we have just studied this. A composite number can be expressed as a product of 2 or more prime numbers, which are called prime factors. Because if it is a prime number, right, we know that the only way to actually factorize or write it as a product of prime numbers is 1 in itself. For example, 3, only how can I write it as a product of prime numbers? It's 1 times 3. If it is 7, it is 1 times 7. And also in a similar way, actually, we can just write this composite number as a product of prime numbers, right? So the decomposition of a composite number into prime factors is known as prime factorization. Now, as I said, actually, you're talking about, I mean, you're studying expression, right? In algebra, also if you're given some kind of algebra expression, we have to learn how to factorize it. Factorize means how to write it as a product of simpler algebraic fractions. Why is it important in math? Because in solving equations, because solving equation is maybe the most important thing in math, right? Because a lot of problems, when you're dealing with problems, you have to model this. After that, you have a mathematical equation and you have to solve this. Solving the equation is a huge task in math. Anyway, in a similar way, if you're given composite number, we can write it as a product of prime factors. So this process is called prime factorization. For example, let's say 4. How can I write it as a product of only prime numbers? We can write it as 1. Actually, 1 is always, we have 1. We don't have to write this. I can write it as 2 times 2, right? 2 is a prime number. Also, this 2 is a prime number. So actually, we have just written 4 as a product of prime numbers. And how about 10? It is 2 times 5. And how about, let's say 35? It is 5 times 7, right? And see here, 5 is a factor of 35 and 7, and each number is, what is it? A prime number. So now, Salim, can you tell me, how about 52? What is the prime factorization of 52?
2 by 2 and by 13.
Very good. And how about 75?
75. 5 by 5 and by 3.
Okay, that is it divisible by 3? Yes, right? It is 3 times 5 times 5. And one more thing, how about 100? Actually,
this is easy. 2 by 2 and by 5 by 5.
2 times 2 times 5 times 5, right? Very good. So now, sometimes some numbers may be a bit long. Like, for example, can you just tell me one more thing? How about prime factorization of 360? How do we do that? Usually we do it like this, right? 360, and maybe I should just write it here. Maybe here, 360, and start dividing with the smallest prime number possible. If you divide by 2, here we have 180. Divide by 2, here we have 90. Divide by 2, here we have 45. 45 is not divisible by 2, so next prime number is 3. Divide by 3, here we have 15. Divide by 3, here we have 5, and here we have 5, and here we have 1. So how many 2? Here I can just write it as 2 times 2 times 2 times 3 times 3 times 5. Yeah, as you see here, every time writing in this way, it's not so practical. So mathematicians actually developed another method to write this in a more compact way. What is it? Index notation, right? For example, we know that if you just 5 times 5 in a more compact way, how can I write 5 times 5? We just do it like this, right? 5 to the power of 2. If you have 3 times 3 times 3 times 3, 3 is multiplied by itself how many times? 4 times. Then here we just write here 3, which is called base, to the power of 4, right? So actually writing this prime factorization, actually we can just write this with index notation, right? For example, here, what is it? It is 2 squared times 13. And how about here? It is 3 times 5 squared. And how about this 100? We can just write it as 2 squared times 5 squared. And how about this one, Salim?
So 2 third power, 2 3 power,
Cube.
3
Okay.
squared,
3 squared, and 5.
Yes.
Okay. One more thing, Salim, after you'll have some break. A factor tree can be used to express a composite number as a product of its prime factors, right? For example, here, if we have 16, and we know that it's divisible by 2, we can just write as 2 times 30, and 30 also is divisible by 2. Here we have 2 times 15. So now here we have 2, here we have 2, 15, we can write it as 3 times 15. Anyway, this is one way of how to say, actually using this tree diagram to find the, what is it, prime factorization of a number. Let's just do this one more example here. For example, what number? Let's say here we have 124. So 124, we can just write it as 2 times 62. And here we have 2, this 62, we can write it as 2 times 31. And 31, as you know, it is a prime number. So 124 is equal to 2 squared, because here we have 2 2's, right? And times 31. Okay. Express, that's the last example, Salim. After that, you'll have some break, 5 minutes. Express 252 in prime factors. To do this one, again, I'll just use this method. That is very practical method. Write 252 and draw a line here, right? And start dividing by smallest prime number. And for the smallest one is 2. So here we have 2, 5, 2. It is 1, 2, 6. Still it's divisible by 2. Here we have 2. So it is 63 divided by 3. It is 21 divided by 3. It is 7 divided by 7. It is 1. So when it is 1, we should just stop this. So what is the prime factorization of 252, or prime factors? Is 2, all right, 252 is equal to how many 2's? Here we have 2 2's, right? 2 factor. 2 squared times 3, 2 3's, 3 squared, and times 7. Okay. Salim,
Yes.
have some break, okay, 5-minute break, and after that we will have 25 more minutes, and after that we'll have we'll finish the class, okay? After 5 minutes, I'll continue.
Okay. Can you please do the other slide, which was so I'm gonna read the explanations too.
Which one?
The one there were like written the explanations, what is what, and etc. Where you explained. Can you do backwards? Thank you. Yeah, this one. Thank you.
Okay.
We don't fall asleep. Can you up there inside? Like you want to play Rocket League? Sorry, I'm reading an Harry Potter book. But like, you want to see me play Rocket League though? No. Actually, no. There's no Wi-Fi. I know what. There's no Wi-Fi actually. Maybe when there's Wi-Fi, I can show you playing it. Okay?
Ay, 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 ay,
What's up?
Hello, Salim. Are you there?
Yes.
Okay. Did you actually see my name and what's up? Did you edit the number?
Which number? I didn't understand.
I mean, my telephone number, and just can you say hi?
Oh yeah. I wrote this. I'm gonna write you now. Can I write you after the lesson? Can you just...
Yeah, I just want to make sure that actually you receive my message, and after that, the other guys also taking this class. Are they your friends?
Actually, I don't know who will take this class in our school because I didn't talk with them.
Okay.
No,
Okay. No problem then. Okay, Salim, let's continue.
Okay.
All right. Because in WhatsApp, I open a group, so we are going to actually send the homework from there. I just want to make sure that actually everything's okay. Salim, let's continue. So now, I think you're a good student and you're doing questions very well. In this way, actually, we can cover a lot of stuff. Anyway, now you have some idea about natural numbers and whole numbers, and we understand what we mean by factor or factors of a number. We mean natural number and also multiples of a number, right? And prime factorization and index notation. Anyway, so now here we have two different concepts here. Number one is highest common factor. And what we mean by highest common factor, let's just have a look at this example. And after that, we'll try to understand. I mean, maybe you know this, actually, we try to gain more intuition about this concept. Sally, can you read the problem or can I see, is it too small for you?
No, I can read. Suppose Mary, an art elective program student, is working on an assignment. She plans to cover a 30 centimeter by 36 centimeter sheet of paper completely with identical square patterns. Can you help her find the side of the largest possible square?
Okay. So in a way, we have one student, she's doing some kind of project, and here she's given a kind of square here. And that square is a rectangle, right? The width of the rectangle is 30 centimeters. It is actually displayed here. And the length or the height of it is 36 centimeters. The question is, what is it? She plans to cover a 30 centimeter by 36 centimeter sheet of paper completely with identical. Identical means exact the same square patterns. So can you help her find the side of the largest possible square? So if I ask you the smallest or the smallest square, it is easier, right? For example, if you're given a lot of 1 by 1 square, all sides are equal, and this side is 1 centimeter. And in this way, I can just put 30 tiles, and also for height 36. How many square will we use here? 30 times 36. But here question is different.
I found.
Sorry?
I divided 35 and 36 by 6.
Okay, good. And here we need to find, right? We need to use the biggest tile possible. So at that time, we need to find a number which is divisible by 30, at the same time divisible by 36. Okay, that is called the highest common factor, because if you just write here, for example, 30, what are the factors of 30? It is 1, 2, 3, 5, 6, 10, 15, and 30. How about the factors of 36? It is 1, 2, 3, 4, 6, 9, 12, 18, and 36. Continue. So now these are the factors of these numbers. And how about the common factors? So this 1 and 1, it's a common factor because a factor of 30 at the same time 36. Also 2 is a common factor of these two numbers. 3, also common factor. And next common factor is 6. And next common factor, do we have any common factor? No.
No.
I can just write here then, what are the common factors of 30 and 36? Common factors are, we just write here, 1,
1, 2, 3, and 6.
and 6. But here the question is the highest among this one, which one is the highest? So
6.
then highest common factor of 30 and 36 is equal to 6. So usually, actually, if you're given any two numbers, then how do you find the highest common factor? And maybe you know this. Actually, we just write these numbers next to each other, like
We find the factors, then the common factors, and then we find the highest factors.
Yeah. And another way is this, every time writing in this way is not a practical way. So we are going to use this method. Let me just write these numbers next to each other and draw a line and start dividing these numbers by prime numbers, right? Actually, here 2 is a common factor. It is 2. So it is 15 and 36. So now I can divide this by 2, but 2 is a common factor. Let me just put here some kind of star here. But 2 divides 36, but it doesn't divide 15. So that's why I'm not going to put star here, right? So here we have 15 and here we have 18. Still, I can divide by 2. 15 is not divisible by 2. 18 is divided by 2. It is 9. So now 15 and 9, both numbers are divisible by 3. So I put star here. And here we have 5, and this one is 3. And still divide by 3. Here we have 1 and 5. And divide by 5. Here we have 1. So here we have 1 and 1. We can stop. On purpose, actually, I'm just writing all of these numbers. After this, we will learn about least common multiple, because the product of all of these numbers, it gives us the least common multiple of these numbers. And how about the star numbers? Here we have this 2 and this 3, right? Product of these numbers, common factors, it gives us the highest common factor of these numbers. So what is it? It's just 2 times 3, that is equal to 6. Okay, let's just see one more example. And how about if you're given 3 numbers here, 60, 180, 210, and here we have 60, and here we have 180, and here we have 210. Can you see what is the common factor of these numbers? Just tell me one common factor.
Two.
A bit bigger. As you see here, all numbers
5.
end with 0, right? How about 10?
5. Yes, 10.
10, right? Because I can actually, it's easy to see that actually all numbers are divisible by 10. Let me just
7.
divide by 10 and put a star here. So here we have 6, here we have 18, here we have 21. And do actually these numbers have a common factor?
Yes.
What is it?
10.
10? 6,
Oh,
18, and 21.
Yes, they have 2. No, 21. 7. No, no, they don't have.
How about 3?
3, 6 divided by 3. This, yes. 7 or 6 and 2, yes.
Right? Also, actually 3 actually divides all of these numbers. But if you look at here, 2, 6, 7, actually they don't have any common factor except for 1. So now we can stop here. Then highest common factor of these numbers, 60, 180, and 210. That's equal to 3 times 10, that's equal to 30. Okay, usually actually you can just use this method to find the highest common factor of maybe 2 numbers or 3 numbers or 5 numbers, doesn't matter. Good. Let's talk about least common multiple. Simon, can you read it one more time?
Yes. Mary, the art elective program student, is working on a second assignment. She first designed a rectangular pattern measuring 9 centimeter by 12 centimeter. She then makes copies of the rectangular pattern. Next, she uses the rectangular patterns to form a square. So the first question, how many rectangular patterns does she need to form the small square? And the second question, what is the length of the side of the square?
Very good. Now, similar question, but it's a little bit different, right? In the previous question, actually, we were given a rectangle. So we have to cover up all the, that rectangle with, what is this, square tiles. But here, you are given a rectangular piece of some kind of tile here, whose dimension is 9 by 12 centimeters, right? So we are going to fill in this square. This is square here. So that means that actually I need to use exact actual number of squares so that it just covers this square completely. What does it mean? It means that here, if the length of the square is, let's say, some number, so that number should be divisible by 12, and also it should be divisible by 9. And we are looking for the smallest one. Actually, we have a lot of numbers divisible by 9 and 12. Among these numbers, we are looking for the smallest one, right? To do this one, let me just first find actually common multiples of these numbers. And we know that the multiples of 9, it is 9, 18, 27, and 4 times 9, 36. It is 45, 54, dot, dot, dot. How about 12?
I think it will be 36.
12, yeah, 24, 36, and here we have 48, and here we have 60. Let me just write one more, 63. Okay, and here we have 72, dot, dot. So among this, actually here, the first multiple, common multiple of these numbers is 36, right? That's the smallest one. And others will be, here we have 72, the second one is 72, but we are looking for the smallest one. And that's why we are saying that the least common multiple, right? So here, the least common multiple of 9 and 12 is equal to 36. So now, if we are looking for the smallest square, then its dimension, actually its length, must be 36 centimeters, right? And how about different way to find this least common multiple, and also a similar way to highest common factor? We can calculate this. Just write these numbers next to each other. Okay, let's just use a bit dark reds. Here we have 9, and here we have 12. And after that, we need to draw a line. So divide these numbers by prime numbers, starting with 2. Here we have 9, and here we have 6. Still, I can divide by 2. It is 9 and 3. And divide by 3, it is 3 and 1. And 3 is divided by 3, it is 1. So when we have 1 and 1, we should stop here. So what is the least common multiple of these numbers? Just we need to multiply these numbers, right? It is 2 times 2 times 3 times 3, which is equal to 36. So the least common multiple of these numbers is 36. Okay, let's take one simple example. We have 2 examples. First with 2 numbers, next one is with 3 numbers. So again, find the least common multiple of 30 and 36. So to do this one, we should write these numbers next to each other, 36, and draw a line. So divide by prime numbers. If you just can't see any big common factor, you can just start with this number. As you see here, 30 and 36, both numbers are divisible by 6. So divide by 6. So here we have 5, here we have 6, and divide by 2, here we have 5 and the 3, divided by 3, 5 and 1, divided by 5, here we have 1. So least common multiple of 30 and
180.
is equal to 6 times 2 times 3 times 5. It is
180.
180. Okay.
Mm-hmm.
Okay. How about this? Another example. Here we have 18 and 24, and here we have 36. So we just need to find the least common multiple of these numbers. So as you see here, 18, 24, 36, all these numbers are divisible by what number? Can you tell me their common factor?
4.
A bit bigger than 4. Any other number bigger than 4? 18 is not divisible by 4. 4 is not a common factor.
6.
That's right. That's correct. So it is 6. So 18 is divided by 6. That is 3. 24 is divided by 6. That is 4. 36 is divided by 6. That is 6. And these numbers actually don't have any common factor. Anyway, let's divide by 2. Here we have 3, 2, 3. And divide by 2. Here we have 3, 1, 3. And divide by 3. Here we have 1. Here we have 1. So actually, when we have all ones, we should just stop. So
272.
least common multiple of 18, 24, 36. It should be equal to 2 times 2 times 3 times 6, which is equal to 4, 18. That is 72. Okay. So now let's talk about squares and square roots. In this picture, in this diagram, what we have here, we have a square. What is a square, Salim? Can you tell me the definition of square?
If we talk in like mathematics, like this square, this.
Yeah, this shape, this figure, this geometric figure.
It's a shape.
Is a shape? What is the definition of a square? What kind of figures are called a square?
Four-angled shape.
So it is a special quadrilateral. Quadrilateral means four-sided flat figure, right? Whose
Yes.
all sides are equal and all interior angles are 90 degrees, right?
Mm-hmm.
So it's a special quadrilateral whose all sides are equal and also interior angles must be 90 degrees. Actually, if these angles are not 90 degrees, then it may become a rhombus, right? You know what is rhombus, right? This is
course.
Rhombus. Okay. Okay, this is rhombus. So maybe all sides are equal, but interior angles are not 90. Anyway, so we know that here the area of this square, what is it? It is 6 times 6. That's equal to 30. So from here, we can just write here 6 squared is equal to 36, right? So these numbers actually, natural numbers, which are the square of natural numbers, we call them, what is it? Perfect squares. What are perfect squares? This is 1, 4, 9, 16, 25, 36, ... Because each number is a square of a natural number, right? 1 is 1 squared, 2 is 2 squared, 9 is 3 squared, 16 is 4 squared, ... So these are the perfect squares. And to get this perfect square, if you just square any natural number, we obtain a perfect square. And how about square roots? Sometimes I may ask you a question. Okay, if I don't know the side of this square, right? And if you are given the area of this square, and you know the area, if I ask, okay, this area of the square is 36 centimeters squared, or square centimeters. The question is, now what is one side of this square? Let's say the side is A. Oops. Side is A, and this side is A. Then we know that the area of the square is A squared, that's equal to 36. Then how do you find A? Now actually using, if you don't know the square root, we cannot express this A. So we have to introduce something new. What is the square root? Then this A is equal to square root of 36, right? What does it mean? It means that square of A is equal to 36, which is equal to 6, right? And also in similar way, how about square root of 81? Square root of 81. That means that what number's square is 81? That is 9. And how about square root of 100? That means that what number's square is equal to 100? That is 10. Okay. All right. So find the positive square root of 784. Okay, Salen, here, for example, with a calculator, you can find the square root, right? Here, we are just going to use different methods. Okay, how we should find the square root of this number or square root of this number using actually the knowledge that we have just learned. For example, 784 without using calculator. How do you find the square root of 784? To do this, we need to find prime factorization of this number. 784, I can divide it by 2. If you divide by 2, it is 392. Still, we can divide by 2 because it's an even number. Divide by 2, it is 1. 19, it is 9. 12 is 6. Still divisible by 2, it is 9. 8. Still divisible by 2, it is 4. 9. 49 is divisible by 7. Divided by 7, here we have 7. And divide by 7, here we have 1. Now, I can just write 784 as how many? 1, 2, 3, 4. So that is 2 to the power of 4 times, and here we have 7 squared. So that is 7 squared. What is the question? The question is square root of this number. Then square root of 784 is equal to, what is it? Square root of 2 to the power 4 times 7 squared. And we know that this 2 to the power of 4, I can write it as 2 squared times 2 squared. Because 2 to the power 4 means 2 times 2 times 2 times 2, which is equal to 16. Or simply, that's equal to 4 squared. So that's equal to, here we have 4 squared times 7 squared. So now, square root of 4 squared. What number squared is 4 squared? It's just 4. Here we have 4. What number squared is 7 squared? That is 7. So the answer is 28. That's just one method of finding square root of big numbers, in case sometimes we may have to find the square root of number without using a calculator. And how about the second question? That is A, and this one is B, 2025, right? So here, if you divide by 5, it is 405. Divide by 5, 101, and 101. Is it a prime number, Salim?
101?
Yeah. Does it have any factor except for 1?
No.
Are you sure?
101.
Wait. Yeah. Here we are dividing 405, right? So it should be 81. That's my mistake. And 81 is, we know that if you divide by 9, it is 9. Divide by 9, it is 1. So 2025, we can write it 5 squared times 9 squared. Then what is square root of 2025? That is square root of 5 squared times 9 squared. And here, what number squared is 5 squared? 5 squared is 5 squared times, sorry, just 5. And what number's square is 9 squared? It is just 9. So the answer is 5 times 9 is 45.
45.
Okay. So that's the last slide, Salim. Let's just do this and I'll finish the class. And when do we have class again? I think today is Monday, Thursday. Okay. Find the square of 15. Find the square of. Here, actually, of is missing here. Anyway, I'll correct this. So you know how to do this. 15 squared. Here, just actually what we mean by this. 15 squared. What is 15 squared? How do we calculate this? Maybe one way is long multiplication. 15 times 15. But I'm going to use different method here. 15 squared, I can write it as 10 plus 5 squared. So to do this one, I'm going to use this formula. Maybe later we'll see this. A plus B squared is equal to A squared plus 2AB plus B squared. So here we have 10 squared, it is 100, plus 2 times A times B, 2 times 10, 20 times 5, it is 100. 5 squared is 25. So that's equal to 225. And how about 35 squared? So we can just write it as 30 plus 5 squared. 30 squared, it is just 900. 2 times 5, 10. 10 times 30, it is 300. And 5 squared, it is 25. 900 plus 300, it is 1,200 plus 25, 1,225. Multiplication, actually just adding is much more easier than this multiplication. Okay, Salim, can you calculate 55 squared and 95 squared mentally? That is your homework. You just have a look. And after adding this WhatsApp, you just say, hi, I will add you to the group. And from the group, I will send your assignment until Thursday. Okay, Salim. Salim, actually, you may know these things. And why actually should we be a good student? Not only for the people, but if you really understand math well, in the future, you will see that it will help you a lot to understand other subjects. And also it really helps you a lot to be successful in whatever you do. Because after all, math is used everywhere. So try to solve questions. If they are so easy, you need to work on your speed, okay? Have a look and try to solve it a bit faster so that in a short time, you can do a lot of work. Salim, that much is enough for today. Nice to meet you once again. See you on Thursday. If you have any questions, you may ask now or later. Also, you can just ask me through WhatsApp. Okay?
I have a question. The
Yes,
one you
please.
showed the solution, it's much more easier for me to do the multiplication than an addition. Can I do the multiplication way?
You mean like this? 15 times 15?
Yes.
Yeah, maybe it is 2-digit number. How about if it is like this, for example, let's say 105 squared. I mean, try in both methods. You will see that this method is much, much easier than this. Maybe when it is just 2-digit number, you may think that it's easy. But now if you just square 105 squared and try this method, 105 squared. What is it? It is 100 plus 5 squared. 100 squared, it is 10,000. 2 times 5, 10. 10 times 100, it is 1,000. Plus 5, it is 25, which is equal to 10,000 plus 1,000 is 11,000 and 25. Now try this one, your method. You will see that actually this method is much, much easier. Maybe when it is small number, like 15, 2-digit number, maybe the multiplication in this way is much easier. But when it is big number, and that method is much, much more practical.
Okay, thank you.
Okay.
So the homework we need to scan, and then in the PDF version we need to send to your WhatsApp.
Yes.
Okay, can you write the name of the app, please?
Name of the app? What do you mean?
You said the cam scanner or something like this.
Yeah, after
Can I
actually
just
you actually send a message on WhatsApp, I will just send you the picture. Cam scan. You can just search like this. There is such an app in Apple Store.
okay, but
And
can I just photo you and send my solutions and answers on the paper that I wrote, or this much more easier with cam scan?
say again, what did you say?
Can I just photo my homework and send it to you?
Salim, actually, when it just take a picture, it doesn't look nice, number one. Number two, it takes a lot of space. And this one, cam scan, you will see that when you just scan, for example, let's say you have 5 pages, okay? And when you just take a picture of this 5 pages, immediately it just combines and asks you when you're sending, do you want to send as a picture or as a PDF file? When you just send it as a PDF file, it just makes a one file, and it is so quick. And after just saving as a PDF file, you can just save your name. I will also give you some instruction about this. That is A1, for example. You will just say that the assignment number will be something like this: exercise 1A, B, C. And maybe after that, you can just put your name here, Salim, because in this way, it's easy for me to have a look and check this. And also this PDF, this is a PDF file. I can just open this with Microsoft Edge, and also I can just write some notes on it. But if you send as a picture, it will be very difficult for me. And also it will be difficult for you. Just try this one, Salim, one time, cam scan. You will see that it's very practical, number one. And when you just sign in this cam scan with your maybe telephone number or email address, all the time it will be here. Even if you don't have telephone, for example, at school or somewhere you want to have a look, you can just sign in with internet, okay, this Google, and you can see all your work here. It will not be lost.
Okay, I understood. Okay. Thank you.
Okay, very good. Thank you very much. See you on Thursday. Bye-bye.
Okay, bye.